Welcome to another GC Basic demonstration. This is part 6 of the GC Basic tutorials and videos for the 18xxQ20. Let's just do the preamble, like the video, let it play all the way through, even if you're not listening to it, because that's measured by YouTube, and subscribe to the channel. That helps fund the project. As I explained in the previous video, open source software is not free. Currently, the costs are about $600 a year, and we need to recover those costs because it's not coming from my wallet. So what we're going to do today is look at using the reset switch as an input and as a true reset. And we're going to have to expand our knowledge of GC Basic and of the microcontroller to make that work. So I've got a prototype board, which I'll show you in a moment. It's a prototype board. It's got 5-volt supply to it, a programmer attached. I'm using a PIC18xxQ20 still. I've got some LEDs and resistors, a potentiometer, and a switch. And that switch was missing from the parts attached in the previous video. But it's essentially attached to port A.3. There's still the potentiometer on port A.0, and the LEDs are attached to port C, 7, 6, 5, and 4. Extremely simple. Let's look at desk camera to see what we've got. 4 LEDs, this is where we've left it. I push that look, and the LEDs go off because that's where we were doing it last time. What we're going to do is we've still got this connected to port A3, but we're actually going to reset the chip and restart it. So we just need to put a bit more code inside of our program to make that all work. So let me zoom up. I'll zoom up for you so you can see this thing. Here's the chip, and at the back edge of it, it's a little rubber connector. So I think it's 40 long. Here's the chip lot. It's connected to this back row. Everything's exposed on this back row, actually in these 3 rows, and I can just put a flying lead in a DuPont cable into a switch that's sitting here, and that switch is pulled up, and it means that it's high the whole time, which is the required circuit for that particular port. And we'll look at the circuit. And these sort of switches in this area here allow me to pull up the switch and then ground it when required. So I can recreate the circuit by moving them about. But essentially, I'll show you the circuit in a moment. It looks like this. We have a switch connected to RA3. And the configuration of the microcontroller controls the operation of RA3. It can either be a master clear, where if you push it, the chip will reset. Or you can actually just define it as an input, and that's quite useful. It just means that you've got an extra port if you need an input, but you can actually use it for the programming cycle as well. And you might have an external event that requires you to reset the chip. But the circuit is shown here. I've got RA3, it's connected through a 1K resistor, and it's pulled through a 10K resistor to 5 volts. Could be 3.3. If I push the switch, it grounds it, and that event will cause the external master clear to reset or become an input port, depending on how we set the configuration of the microcontroller. So it's either an input or a master clear. And as we saw in the previous video, the default is just an input. My board, in actual fact, has a reset on it. And if I push the reset, all it does is become an input port. So what we're going to do is we're going to use RA3 as an input, and we're just going to change the program so it just flashes an LED, so we can see that every time we push the reset, we get a sort of reset signal. We can see a reset signal. And then we'll change that to become a master clear or as a reset. So initialize it, we're going to flash the LED, we do a loop forever, and if the reset button has been pressed, okay, it will set the LEDs. If it's not been set, it will do nothing and just loop back. Now, if it then had a reset, it will actually flash the LED again. It will come back through and do the reinitialization and flash the LEDs. So we have a good program to show the master clear working. So let's look at the sample code and review those results. Where are we? On the screen here, we got the program 70. What we want is program 80. So I'm just going to press the, get rid of that, go back to the cow, Control B, open up my list. I've got the filter turned on here on the right hand side. And here we go, 80080 using the reset. I've clicked it, Control B to shut that window down. And here's the program. You've seen all this before, okay? So if I sort of take this and indent a little bit, I can get rid of that. Oh, it's all gone. We didn't want that now, did we? Let's start at the top, though. I didn't mean to do that, I tell you. Let's start at the top. What have we got? That looks the same. Zoom in. It is the same. What we've got is the chip and option explicit, which means we need to define our variables. Now we've got the thing called config. Master clear equals external master clear or internal master clear. Well, where do we get this from? Well, there's a couple of ways you can understand what the configuration for every chip is. You go read the data sheet. Well, that's not really what GC Basic is about. We want to make it simple. So what I'm going to do is I'm just going to show you a very quick way of understanding the configuration. Press function key F4, brings up the list, type in PIC, PIC, and select PIC info. Here's PIC info. It opens it up. There we go. It's opened it up. A bit slower than I thought this morning. Let me just move the screen around so you can see it. Maybe I'll zoom in a bit further for you. There you go. You got the whole thing. And this is the dialog. There we go. If I type in search 18xxQ20, it will give me on the right hand side of the screen here the configuration for this chip. Now, if you don't believe me, you can go and read the data sheet by clicking this icon here. You can go to the web page, you can look at the erratas, you can learn how to program this, but generally that's the device dashboard. There are other icons at the top here or exits here, and they are very much around going out to our tool chain. So PPS tool, we'll see that later, the editor preferences, which we've seen, and the IDE itself. And that will open up a particular file. But on the right-hand side, look, we've got the configuration. If we just pull down in here, here's the master clear, look. Master clear, M-C-L-R-E, and it has two options. And the default is internal master clear, and that's the star. So all these are the defaults that GC Basic select. And that's quite good. And you can take a copy of that configuration and insert it in your program. But essentially, I put that in the code for you. So internal master clear, copy that, and we'll go and put that in our program. Let's go back to our editor. And that's what I'm going to paste into here. Look. Internal master clear. Then same program we got before, all the constants to set up our LEDs. I've defined it as the reset button this time so that you understand that this is the switch that was there in the previous video, but I've called it reset for a particular reason. And I'm also going to change that to uppercase. Function key F2, upper. If you type in transform to upper, it will transform to uppercase. Look at that, look. Brilliant. And now I can do Control H. I can then replace all my instances of the reset button for uppercase. Personally, you should have all your constants in uppercase, then you know that it's a constant. Okay, reset button, A3, and set it as an input. This is set automatically in reality. You can't set it as an output, you'll get an error, but I'm just doing it for clarity. And then what I'm going to do is every time this chip resets, I'm going to flash the LED 10 times, on and off, 5 times actually, because it's a reset. I'm going to flash the LED, and then I'm going to say if, do it forever, if the reset button is in one state, make it 0, set it to 1, if not, set it to 0. Now, because it's an input, we're going to see the LED flash 7 times, sorry, LED 7 flash a few times as it resets. And then if it's an input on RA3, we'll see LED 6 change. Let's program it up and go out to this cam. We're expecting the blue LED to flash a number of times, which it did. This switch here under my finger is A3. If I push it, our LED with constant LED 6 is coming on and off. So we now know that if we reset the board, it will flash. And I can reset the board by taking the power off. And if you look at just here, you can see there's an LED that's turned off now. That's the power LED. Turn it on, it flashes. So we know that when this chip resets, it's going to flash that blue LED. Back to our program, we're going to change one thing. We're going to change this internal master clear to an external master clear. Control V. Program it. Straight out to Deskcam. We might as well wait here. We're going to see this flash as it boots. It's now just programming it. Fine. Let's just prove the state. We're going to unplug it. This bottom LED has gone off. It's flashed. I push the button and it flashes, which means that we are resetting the chip. So this particular board has a reset switch on it. I'll show you that. Zoom out. Right up here, look. It's a reset. If I push that, we get, and that's on the same circuit. It's essentially exactly the same circuit. And this is how, if you want to have an external reset, you would set the config to enable you to do that. So the configuration itself is quite important. And how you can change the configuration in GC Basic is very simple. I've shown you how to do it. If you want to change the configuration, use PIC-info. You can say, I want to change the protection mode, set it to on, do it in here. If you want to change, let me just think, whether you can change certain parameters in the memory, then you could do it in here. And we'll come back to this about what's called domains. If you wanted to protect the EEPROM, you would go CPD on. And then you would copy that config, and it actually has taken a full copy of the configuration. You can go into your program, and you can paste the whole thing in. And that way, you know that your configuration is correct. And it will actually then still compile, and it will compile a consistent configuration. But the configuration could be different for various chips. So one chip might call it one thing, another chip might call it another. So you really should use either the data sheet or PIC-info. I'll delete that because I don't want that in the sample code. So PIC-info is quite useful. If you want the data sheet, just click on that. You'll see it just flash up. It actually downloads a little file, opens up, and it's taken us directly to the data sheet for your perusal. So that's quite a useful tool, and it has a lot more information in it, and we will come back to PIC-info later on. Nothing else to show, but what we've learned is we can change the configuration of port A.0 to be a reset or to be an input port, and that's how you do it, by changing the master clear. And the master clear, if we look at that in the data sheet, Control F in the data sheet, you will see reams and reams on the data sheet, which configuration byte it is, what the state is, it says here if it's a function or not, and you can read merrily the data sheet how master clear works. So we'll move on. So what we've done so far we've looked at the hardware, made the LEDs flash, make them work in sequence, we've got the ADC, we've used the ADC value to change the delay, we've got inputs working, we've been able to use the reset switch as an input or as a master clear reset. So why don't we just bring that all together, and we'll actually then have the LEDs flashing in a sequence, and when you press the button, they'll go into reverse. And that is a standard demonstration of a chip capability. We will then move into serial, we'll move into timers, PMW, etc. And we're actually going to do some really clever graphics later on, okay? And we'll do all that in these videos. So let's call that a wrap. Like the video, subscribe to the channel, watch it all the way through, or let it run. Thank you. Enjoy.